Right, well, being a mathematician often feels like being a child that just gets to play with increasingly more sophisticated toys throughout life. And sometimes these toys actually get to resemble some of the ones we enjoyed in our childhood. So I want to give you one such example that starts with Lego and goes all the way to my PhD thesis, right? So we all sort of have an idea of what Lego looks like. You start with some basic building blocks and you stack them together to create whatever your imagination comes up with. So here you see a Lego pair of pants and the Lego cap that for no obvious reason I decided to just glue together to get something. And then, as you grow up, you learn about topological spaces, but your inner child cannot help but wonder, is there a way to use Lego-like constructions to create interesting topological spaces? So it turns out that that same pair of pants and the same cap you can use to create pretty much any reasonable two-dimensional space you can come up with. You see what that looks like for the torus over there. And there is more, because mathematicians were so proud of the constructions that we make, right? We don't just want to build a space and throw it away. We want to somehow collect all of these constructions together. And the place where we collect all of these Lego-like constructions together is this mathematical object called the Bordism category. But just like children, we are never satisfied with the toys we currently have, right? We always want more toys. And when playing with Lego, one thing that comes up is that usually we use Lego pieces that we can glue together in multiple directions and not just one. So our inner child, again, cannot help but wonder, can we do that in this case? And the answer is yes, of course. Actually, if you use the saddle and the half cylinder and the cap, you can actually create, again, all reasonable two-dimensional spaces you can come up with by gluing them together now in two directions. And the mathematical object where we collect all of these things is the Bordism category. Now, this is what leads us to the question in my thesis, which is there a higher dimensional analog to this story? And turns out, yes, there is. It's a little bit difficult, but as they say, double the pain, double the fun. So I've just been basically building these higher dimensional analogs of Legos that you can glue in two directions that can create for you almost reasonable higher dimensional spaces. They look like diagrams as the one shown here, and those diagrams get to encode a mathematical operation called surgery, hence the title of my thesis, which is Surgery Representations of Bordism Bicategories. And it turns out that in dimension 3, you just need finitely many of these guys to describe all reasonable three-dimensional spaces you come up with, which I think is pretty cool. And that's what I had for you today. Thank you.